Hey everybody, it's Mr. Farnsworth. I've been having lots of people wondering how to do this Karyotypes teacher graded assignment, so I just want to go over a few things. First, be sure to go ahead and read the different things. That way you're familiar with what a karyotype is and what the whole purpose is. And when you get here, it's going to give you some information about karyotypes and different syndromes. That is important because that's going to help you pay attention to what you're doing in the lab and what that effect means. So that'll help you to answer the questions that will be on the teacher graded assignment. Right there is the teacher graded assignments. We'll go over that part later on. And you will need to turn in a diagram or a picture of the karyotypes that you're making. So, if you're going to make it with piper cleaners and everything, there's the information you need. If you don't want to do that, you can always just draw it on the computer, which is what I'm going to do. So right here, step 1, if you click on reveal, it'll tell you the information. This is going to be how to do it on the pipe cleaner. If you click on step 2 and click reveal, it's actually going to show you kind of how to do it. So it says, if you're making the model via paint program on your computer, draw 23 line segments of about the same size and length. Each line segment will represent a chromosome. So, basically, all you're doing is you're drawing sets of chromosomes. So let's start off. You just gotta grab the tool, paintbrush, choose a color, go with blue. Let's go with green. I like green. You're gonna just draw sets. So set 1, set 2, 3, 4. Again, it can be as fancy or as simple as you want. I guess technically right now we're not supposed to. Notice right here on step 3 it says if you're making label 1 to 22 and then write down X on the bottom. So 5, 6, 7, 8, 9, 10. Ironically, that's 11, 12, 13. And again, notice they don't all have to be the exact same size as long as they're about the same size as each other. We're going to pause the record. So I was reading the instructions and I realized I kind of cheated. So right here it says draw each line. And then segment 4, go ahead and label them X, Y, which ironically I labeled that 23. Let me fix that real quick. But ironically, you're supposed to put out all 23, and then step 5, you go and make them all the partners. Alright, so right there. Go ahead and label it all. You make a copy. Go ahead and pair them all up. So this one's X. Each pair of chromosomes label and notice these are the exact same size. This is going to be important. Again, we made 2 of the exact same size. So again, if you're making the model by hand, add additional pipe cleaners to addition 21. An individual has an additional chromosome 21 suffers from Down syndrome. So right here, we go to 21. We're adding 1. This is going to create a Down syndrome. So that being interesting, I'm going to go ahead and circle that in red to catch my attention so I don't forget about it later on. Okay. Now we'll keep on going. Go back to green. Here we go. Step 6. If you are making the model using the paint program on your computer, use normal and additional line segment pair percent 21. So again, you can label them as normal and Down syndrome and then save it, or you can keep it separate. As long as you kind of keep it all together. I'm going to write here, Down syndrome. Okay. Step 7, click on it, click reveal if you're making the position. Remove the additional pipe cleaner you added in step 4. So again, you would delete this. Now remove one of the X chromosomes. So now we're going to take away one of these. You can just kind of cross it out, or you can go ahead and erase it. And if you do that, and again, you can save all the separate files, so that'll make it easy to instantly know what's going on. Or you can just label it and circle it. And just call it Turner syndrome. Okay, step 8, same thing. If you're making the model using paint programming computer, type in normal. For the 24 per label, an individual who has only one X chromosome suffers from Turner syndrome. Okay, we already did that. Number 9. If you're making the module return the X chromosome, you return. So you can return it if you want. Now cut off the portion of one of the persistent X in position 5. So notice these are about the same size. All you have to do now is cut it in half. Then of course I'm going to go ahead and circle it. That way I can easily see it. You don't have to circle it. You just got to make sure it's significant. Now this is called a cat cry syndrome. So I'm going to just call it CCS. Go on, move to step 10. Go ahead, save the file as a separate file. Now you make a model by hand. Replace the cut chromosome with the normal length chromosome. Now cut off a portion of both copies of chromosome 7. Now notice it says from both copies of chromosomes. So now I want to go ahead, cut off a piece right there, make it half the height that it originally was. And again, I'm going to go ahead and circle it, and I'm going to go ahead and label it cystic fibrosis, or CF. Okay, I think that just says do the same thing. There we go, and there you go. So that's all you have to do. Now notice you had to click on each one to do it. Now we can actually compare this to this. So right over here, what sex is the person who has the karyotype described in steps 3 and 4? 3 and 4 said you had 2 of them right next to each other. So if you had 2 equal sized chromosomes, think about it. Does that make it XX if they're the exact same size, or XY? Would that be 2 different sizes? That's for you to discover. In what ways the mutations described in steps 5 to 6, 7 through 8 differ from those described in 9, 10, 11, and 12? So notice these 2 were adding and deleting chromosomes. These ones were cutting away pieces. Literally, tell me the difference between that. In steps 11 to 12, you saw that cystic fibrosis is caused when a specific section of both copies of chromosomes 7 are deleted. On this basis of this information, do you think cystic fibrosis is a dominant or recessive trait? So what do you think? If it has to happen to both in order to be expressed, is that a dominant or recessive trait? What do you guys remember about dominant and recessive alleles? Do all mutations result in negative effects? Go ahead and tell me. Are all mutations bad? And that will get you through the paper. Hopefully that answers any questions you might have. Make sure if you do have any other questions, you let me know in an email or something.